Hello, everybody, and welcome to episode 131 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, that is Gavin, and that is Fia. And how you doing, guys?
I'm good.
Yep, living through, some recent snowstorms. I'm sure you can relate, Mike.
I mean, like, snowstorm, like, that's, storm. Like, I've lived through snowstorms, but...
Have you ever lived through a hurricane?
Here recently. Wait, say that again?
Have you ever lived through a hurricane, though?
Lived through a hurricane? No, I haven't lived through a hurricane.
Not like Florida hurricanes. Sometimes they do make their way up the East Coast, but not like Florida.
Yeah, but that's some rain. That's not a hurricane. Have you lived through a hurricane, Fia? Go ahead, tell your little hurricane story.
Well, and I don't remember what year it was a couple years ago. Hurricane Ida came and hovered over where I was living in Houma, Louisiana for 15 minutes. I wasn't there.
For 15.
It was like the eye of the storm at peak land performance. It was there.
Hurricane Ida was in 2021, apparently. Category 4.
Yes, it was a doozy.
Peak land performance.
I mean, like, water performance is different. Because, like, once it hits land, like...
Yeah.
It just kind of gets tired.
Yeah.
Gradually.
Is that the official scientific term?
Yeah.
Yes.
Gets tired? Okay.
Yep, sure is.
Absolutely.
But yeah, there's just been, like, a bunch of weird storms, like, very on and off again here in sort of central Pennsylvania. Like, there was one night where just overnight, it only was, like, from midnight until about, like, 6 or 7 a.m. We got, like, 4 to 6 inches, depending on where you were. And then a couple days later, it was, like, 50. And then a couple days later, we got another, like, 3 inches. So it's been a weird, like, week and a half.
See, and that's one of the biggest disappointments of winter now, because, like, we were young, it would stay cold for months on end, and just, like, you'd have snow stacking out, you'd have, like, months of snow just piled on top of each other. Now it snows and melts and snows and melts.
Yeah, I remember when I was a kid, I used to, me and my sister and some of my cousins used to make, like, tunnels in the snow in my parents' front yard.
Yes. Nice.
And now there's just never enough snow to do that anymore.
Mm-hmm.
Good times.
Oh, yeah. All right. Now that we're done, sitting around the bar talking about how many tackles we had against Lakeland in 1984 and how angry the kids are making us.
I don't even know what that's a reference to be honest.
It's not a reference to anything. It's just, we're old guys sitting around the bar being like, oh, you remember the good old days?
Sure.
Like, we used to make tunnels in the snow and, you could go down to the shop and buy a pop for a nickel because they called it pop back
in my day.
Yeah, right. So anyway, Fia, do we have housekeeping?
We do. So, of course, every other week, I come to tell you, don't forget to rate the show on whatever platform you listen to us on, and to follow us on Twitter, Facebook, and YouTube, and give us feedback about the show, and any future topics you would like to hear on the podcast. And if you'd like to be a guest on the show, which we'd absolutely love, be sure to fill out our guest form. All of this stuff can be found in the show notes below in whatever platform you listen to. And with that, Gavin, what is the next episode topic?
Yeah. So I reached out to one of my friends. We started at Bucknell at the same time. He's in the biology department. So I reached out to him to see if he'd join us as a guest next episode. Haven't heard back. I just reached out to him today, so I didn't really expect an answer today. So maybe a guest episode in a couple weeks. But if not, if it doesn't work out for him, or he's just not interested, which, I get, we're going to be talking about whales. Because after doing some of the research for this here episode, whales are real neat. And I could have sworn that we already did an episode about whales. But I looked through the back catalog and we hadn't, which surprised the heck out of me. So that's what we're going to be talking about. Otherwise, we're going to be talking to one of my friends about ants. So, either or.
Cool.
Yeah.
My vote is on whales.
I mean, we'll get to both eventually.
Yeah.
But yeah, so with that, Mike, before we started recording, you said this was not a particularly happy today in history. What did you find for us?
Well, I mean, it was happy for some people.
I don't like that.
So I'm trying to think of how I want to intro this. French things. Name some French things that might get talked about in a history class.
French Revolution.
The French Revolution? Yeah,
French Revolution. What did they do in the French Revolution?
Kill people.
Killed a bunch of people.
How?
With guns.
And beheading.
Yeah. Yeah, the guillotine. So today, February 21st, in 1793, King Louis XVI of France was executed by guillotine. They got King Louis.
Oh.
Yeah.
How exciting for some people.
Vive la France, I guess. Vive la Resistance.
Yeah. Poor guy. Yeah, and then his wife was like waiting around for a while. I mean, look, did he deserve it? I feel a little bad for the guy.
Maybe.
Did he deserve that? Like, no. Like, did he deserve to not be king? Well, no one deserves to be king. Like, that's just stupid.
Preach.
Yeah.
All right, Gavin.
No, I am very much for the state not being able to kill people, and that should also apply to former
mobs of
royalty.
people.
Yeah.
Yeah. Okay. All right, do the science stuff now.
Yeah, science. So.
Wait.
Oh no! Other different science. I'm so sorry, Fia. Mike had me in the zone.
I know.
What do you got for us for Seagrass Corner?
I even came prepared this time.
Seagrass Corner it is.
Seagrass Corner. I would like to talk about the polka dot batfish, which is...
Did you just go to a British accent?
A polka dot
a little
batfish.
bit. I definitely heard it.
I'm offended as an American.
Sorry, guys. Sorry.
I mean, we did just have a little conversation about executing royalty.
Yeah.
So, Murica.
Anyway, the polka dot batfish. It is an arrow-shaped fish in the family. I'm gonna butcher this. Ogocephalidae.
Yep, that looks about right.
Yeah,
that's a word.
So they're basically related to those that fish in Finding Nemo, in the very dark trenches with the little light.
Oh yeah.
They are very distant related to those guys, but. Okay. They are, they range within the Atlantic coast from North Carolina, Florida, Bahamas, Mexico. They can get up to they can be in up to 230 feet deep water, but most of them are found in shallow, sandy, muddy seabeds, coral reef, or seagrass meadows. And so these guys, they are, how do I describe them? Imagine an arrow that is flattened top to bottom and that sits on the bottom of the seafloor. But it has feet.
Okay.
Oh.
It uses its pelvic fins essentially as feet and its side fins as arms, and it kind of walks along the bottom of the floor side to side. It is a very silly thing to witness.
Yeah, it sounds silly. So, listeners, pelvic fins are the ones back toward not the end of the tail, kind of in the middle of the body of the fish.
Yeah.
Where the butt would be if fish had butts like that.
I mean, yeah, more or less. Well, I mean, their butt is right.
That's where the anal fins are.
Yeah.
Wait, there's a thing called anal fins?
Yeah.
I love this planet so much. Keep talking.
So for these guys, its pelvic fins are kind of pushed up forwards, more towards its mouth. And its fins are kind of like bat wings, where they're bent and facing forward.
Oh.
And so it can kind of use them to touch the bottom and kind of wiggle its way on the bottom. Yeah, you really need to look at this thing. It's very hard to describe.
As I tried to type quietly.
But anyway, the polka dotted batfish.
Oh, okay. I've definitely seen these before. I did not realize that those were its pelvic fins. Weird.
Yeah, I didn't either. I was like, well, why does he have feet? But given their name, they have dark brown spots along their body to camouflage, and they are ambush predators, so they'll basically camouflage, wait around for prey to come by, and then they'll snatch them up. And something really cool about these batfish is they have an elongated rostrum. So basically, that's just scientific jargon for they have a unicorn horn in between their eyes. And this little nubby horn contains a chemical that basically will attract the prey. And so they use this little thing, and that's where I think they kind of are related to those deep sea predator fish from Finding Nemo. Anglerfish, yes. Sorry, I was forgetting the word. But
no, you're good.
Yeah, they have like a really tiny, small one that secretes chemicals. And so, yeah. One last fun fact is that I have now acquired a pet batfish. And
oh, really?
Yes. I have named him Bruce Wayne after Batman.
I love that.
Is it what?
Is it like in your actual like house, or is it in your lab?
It's in my house right now.
Interesting. Saltwater tanks seem so hard to take care of.
Yeah, well, he's kind of brackish, so...
Okay, all right.
I don't know. It's not really that hard. He's still stressed. We're trying to figure out how to get him to eat, but we're working on it.
Jeez.
I think he needs live things.
Gotcha. Yeah, it's...
Okay.
Yeah. Any pet that's, like, more exotic than, like, a cat or dog has, like, so many different quirks. Like, I know my pet lizard, who is, like... It's a leopard gecko. It's one of the most commonly kept, types of lizards. There was this one time where she just didn't eat from, like, February until July.
What?
Just didn't eat. Just didn't want to. And, like, barely lost any weight. Didn't get noticeably thin. I would put food in her tank. And she just would not... Just had no interest. She definitely recognized it was food. You could, like, see her react to it at first. And then she would just turn away... and then I took her to the vet, got her like x-rayed and everything, and they were just like, no, she just doesn't want to eat, I guess. And that's all they told me. And then one day she just decided to eat. So.
Wow.
Yeah. And it wasn't even like right when I got her either. It was like over a year that I had her. And then she just decided to go on a little fast.
Okay, well,
A little fast.
Hopefully that's what Bruce is doing, and then he'll be okay.
Yeah, exactly. Awesome. Thank you for that, Fia, and I hope all the best for Bruce Wayne.
Thank you.
But with that,
that's fantastic, by the way, Fia. Well done.
Thank you.
Yeah. So with that, let's get into the main topic of the episode, talking about the Eocene Epoch, and I'm gonna need a little help coming up with a title for this episode. So keep your brains working, you two, throughout this episode. There's not a good snappy thing to call this episode.
Can we just call it Batman?
Well, we gotta kind of say what the episode's about. There are bats. We do talk about bats in this episode. I'll say that.
I'm gonna double down on that then.
We'll see. We'll keep that as a backup.
Okay.
But yeah, keep your brains moving. So, with this episode, we sort of continue our little series marching through all the different subdivisions of time with this here episode. For all the other episodes that we've done, see episodes 50, 59, 66, 72, 81, 89, 98, 107, 113, and 126. We've done that. See also our new playlist on YouTube that I'm going to make with all of these sort of in chronological order. So,
hell yeah.
Yeah, so if you are an earth science teacher out there or something and you want your students to learn all about, the history of life, it's a convenient little place to send them. So, we've brushed up against the Eocene Epoch in so many episodes on this podcast, like way more than I initially thought before I actually went and kind of looked. So, obviously, the last episode in this series, 126, which was about the Paleocene Epoch, the one right before this. So we talked about it basically just being like, hey, the next one is the Eocene. But we've also talked about it in basically every episode we've done, like, about a group. So basically, episode 8 and 9, where we did the whole geologic timescale that's relevant to this podcast, with things like where time periods that had life. That was the 600 million years and 60 and then 120 minutes. Episode 17 about horses. Episode 21 about flight and the evolution of flight. Episode 26 about elephants. 39 about plate tectonics. 46 about rhinos, manatees, crocodilians. Our episode about amber. Episode about camels, about primates, about the different continents that we've done. Episode 97 about bats. So many episodes have brushed up against this time period. So this is a very important time period, particularly in the evolution of mammals, as we're going to talk about. So let's get into it. The Eocene Epoch lasted from 56 million years ago to about 34 million years ago or so. So about 22 million years. So this is one of the longer time chunks between when the dinosaurs went extinct and now. The Paleocene was the 10 million years right after the dinosaurs went extinct. And that was when life was really experimenting, trying to rebuild after that big mass extinction. And then this is after life had sort of bounced back a little bit. This is it sort of culling out all of the real freaks that were around in the Paleocene and getting more into the established groups that would continue on, for the until today. But as always, before we talk about the life and the things that were the critters that were running around at the time, let's talk about what the non-living things on the planet were up to.
Sure.
The continents, by and large, were in pretty much the same places that they are today, with a couple very notable exceptions. Antarctica was not quite centered on the South Pole like it is today. It was still very far south, but not as far south.
Yeah. Do we know what the ice situation was? Because unlike the Arctic, there's quite a lot of actual land under Antarctica. Do we know how much of the ice sheet was still there at this time?
We will talk about it later on, but in general, there was seasonal ice. So just because, as we'll talk about in just a little bit here, the Earth was very, very warm during this period. Mm-hmm. But, things like, the Arctic and Antarctic being cold and not having sunlight for weeks or months at a time in the winter, that still happened. That has always happened as long as the Earth has been tilted. So it would still be winter for months at a time, but all of that snow and ice would melt come summertime.
Okay.
Until the end of the period, spoilers, when Antarctica gets its first permanent ice sheet. But we'll talk more about that later. Let's see. Other southern continents, like South America, was a bit more south than it is today. It had just recently split off from Antarctica, but it was its own isolated continent by this point and was just a bit more south than it is currently. Australia was still connected to Antarctica at the beginning, but would split off around 45 million years ago. Once this happened, this sort of opened up and left Antarctica completely isolated. It had no other land masses around it, and that's sort of what allowed the ocean currents that currently completely circle Antarctica, called the Circumantarctic Current, to just sort of spin around Antarctica, which sort of accelerated its cooling, because there was no warm water coming down there from any currents to sort of help mitigate that. I have in my notes here, that's a surprise tool that will help us later.
Is that a Mickey Mouse reference?
Yeah, it sure is.
Okay. Well, we got Batman and Mickey Mouse so far.
Yep.
And King Louie.
Oh, yeah. Can't forget the king. Other things, like the subcontinent of India was mostly still on its own. It was still moving up toward Asia. pretty early on in the Eocene, it would begin colliding with Asia. So there were a handful of like fairly large islands in between India and Asia at the time. Throughout the period, it would just sort of crash into one of those islands, but keep going, and then crash into another one and keep going. So it sort of gathered all of these islands and smooshed them up into Asia. And that is what now forms the Himalayas. The Himalaya mountains would start to rise, but would, by the end, still not even be nearly the size they are today. Europe, because sea levels were really high at this time, because there was no ice, permanent ice to sort of lock up that water. Europe was still a series of islands for the most part. To sort of go along with not having ice. The climate was extremely warm at this time, particularly at the start. Global average temperatures, and we've talked about this. We had a whole episode about not just about the Paleocene, which I said episode 126. We had a whole episode about just the transition from the Paleocene to the Eocene way long ago, episode 32, about the Paleocene-Eocene thermal maximum. Long story short, like I said, we've got several other episodes talking about it. Long story short, this time period where a ton of carbon from various sources, mostly thawing of frozen methane at the bottom of the oceans, that thawed and went up into the atmosphere, raised temperatures a lot, but for a very short time. And that kind of becomes a pattern throughout the Eocene more broadly, is that the climate is just kind of wacky, particularly in the first half or so. But in general, at the start, the average global temperature was about 27 degrees Celsius, or about 81 degrees Fahrenheit. Toward the end of the epoch, it dropped to about 20 degrees Celsius, or around 68 Fahrenheit. For comparison, today the average global temperature is about 14 Celsius, or about 58 degrees Fahrenheit. So it was, especially at the beginning, over 20 degrees average global temperature warmer Fahrenheit, which is enormous.
Wow.
If you end up going into, looking up anything about paleoclimatology, you will learn very much about the Eocene, because it is, like I said, just weird. It starts off weird with the Paleocene-Eocene thermal maximum. In a span of about 6,000 years, the temperature jumps up somewhere between 5 and 8 degrees Celsius, stays that way for about 200,000 years, and then drops back down. Like I said, likely because of all that thawing methane going into the atmosphere. But that's just the big one. There was another one only a handful of million years later, where temperatures spiked right back up to where they were during the thermal maximum, and then went back down. That one doesn't seem like it's from methane. That one seems like it's more potentially from some weird quirks with some space stuff that I didn't quite understand. Sure. That's always kind of a get-out-of-jail-free card with some things in the past. Is like, well, maybe an asteroid hit somewhere that we haven't found the crater for. Maybe the Earth was orbiting, some weird cosmic thing with like the Earth's orbit and like its path in the solar system lined up weird, and that could have caused something. Sure. And that, I say that kind of dismissively. Those are real things to consider when you're talking about times this long ago. It's
just hard to prove a negative.
Exactly.
Like it's almost not even worth discussing. Like in some context, just because yeah, that's possible. There's a lot of things that are possible.
Yeah. And there is I don't personally understand a lot of the different evidence that they use for these kind of things, but there is some kind of measurable evidence for it. I'm not a paleoclimate person or a space person, so I don't really understand those pieces of evidence, but they do exist. Weirdly, during this time, when it wasn't these weird warm spikes, it was still pretty warm, but it was weirdly very non-seasonal for what all of our climate models kind of suggest it should be. Even with as warm as the globe was, there should have been some bit of more seasonality. And the fossils kind of go to show that there really wasn't much of it, because we find, I think the genus alligator shows up in the Eocene as far north as like northern Wyoming, even up into Canada.
Whoa.
Yeah. So, today, alligator mississippiensis, the American alligator, is the most cold-tolerant crocodilian, and it only really gets as far north as, like, southern North Carolina. That's about it. Yeah. And so to be able to tolerate, Canada, that just goes to show that they weren't migratory. Alligators are really, they kind of hang out in the same general place their whole life. So they weren't going north for the summer and south for the winter. So it must have been warm enough year-round to sustain them, even though, based on our climate models, it kind of shouldn't have been. But that's what the fossils tell us. So a lot of weird, quirky things going on with the climate around this time. After some of these warm periods in the beginning, though, generally the Eocene cools down. Still much warmer than it is today, but some things like the growing of the Himalayas and the Rockies continuing to grow. As more rock gets exposed, that rock absorbs carbon dioxide out of the atmosphere, and that lowers global temperatures. That's a very well-known phenomenon over long spans of time. Then, around 41 million years ago, another large warm spike. Again, not quite sure why. Lots of different factors, again, but the chemical signals don't seem like it was methane or anything. Bumped global temperatures by a few degrees Celsius for about a million years, then went back to cooling. Hard to sort of figure out exactly why at some of these times. Again, if you look more into it, I'm sure that people have more answers than how I just described it, but less straightforward than the initial thermal maximum there. But as this cooling goes on over time, as Antarctica continues to move down into the pole fully, it gets surrounded by its own current. Generally, the trend is, despite some of these anomalies, warm and humid at the beginning, cooler and more arid, not necessarily cool, but cooler by the end. And then, at the very end of the Eocene, Antarctica, like I said, gets its first permanent ice sheet for the first time in around 300 million years. Maybe 200, closer to 250 probably, but since the early Permian period. And so these ice sheets were mostly confined to the center of the continent, not covering the whole thing yet like it does today. And even though we're still... I was
going to ask, like, how extensive was this?
Yeah, still pretty confined to the very center, because there's evidence from this time of forests still around the sort of outskirts of the continent.
Antarctic forests?
Oh yeah, there's always been forests there up until, probably like the mid-Oligocene, so probably about 15, 20 million years after this.
Man, I would love to go explore some Antarctic forests.
I mean, and they wouldn't be like rainforests. They would be, actually, they'd probably be relatively simple, especially at this time in the Eocene.
Let me
similar to
rephrase what I said before.
Yeah.
Let me rephrase what I said before. I don't need to go see an Antarctic forest. I want to go and see an Antarctic tree. Like, it doesn't have to be a full forest.
Yeah.
Like, give me just a real tree down there, and then call it whatever you want. But that's what I want to see.
But the forest probably would have looked not all that different than the forests in New York currently.
Really?
Yeah, and we'll talk about it when we talk about the plants during this time, because the plants are shockingly similar to what there is today. But maybe a bit more north. It wasn't quite totally conifers. It probably would look something similar to like the transition between like the rest of New York and when you start getting up into the Adirondacks, when you still have lots of deciduous trees, but you get more proportionally of like pine trees and stuff like that. And just for anybody who's listening to say why specifically we're talking about New York, that's where all the three of us are from. But yeah, so that's Antarctica. And then all of those weird climatic systems, like I said, if you're interested in climate at all, go read some about the Eocene. Really interesting stuff going on at this time. But that's enough about the non-living things. This is a paleontology podcast. So
let's talk about the stuff that it's also not living, but was at one point.
Yes, not currently. Well, some of it, a lot of it. This is when, particularly in the non-vertebrates, a lot of the same genera that we have today pop up around this time. So starting off with the plants, plants are always kind of what you should really look at to understand what the global system is doing. A lot of times, especially people who study animals like myself, look at plants as like the background, but it's like plants really tell you almost everything you want to know about an environment.
Okay.
But at this point, angiosperms, so these are your flowering plants. If you're thinking of a plant that's not a pine tree or like a moss, it's an angiosperm. They had definitely taken over the world by this point after, starting to become more common at the end of the Cretaceous period. But they were the basis of pretty much every terrestrial ecosystem at this point. Forests covered pretty much all of the land, including, like I mentioned, some of the polar regions. Tropical and subtropical plant fossils have been found in places as far north as Alaska and Greenland, including even things like palms have been found in Alaska.
That's so cool.
Yeah.
Wow.
Yeah. A young upstart group of plants called grasses. For more on grass, see episode 102. They were around at this time, but they were doing pretty well for themselves. But they definitely weren't the dominant force that grass is today. Instead, for the most part, they were confined to some of the wetter areas like stream banks, lake shores, stuff like that. But all said and done, forests look very much like they do today. For example, the modern genus of oaks, maples, birch, aspen were all around and were, like I said, kind of the dominant trees at the time. So forests themselves would look very similar to what they do today. The big exception with plants, like I said, is the absence of things like grasslands, prairies, and savannas. Those just did not exist at this time.
Yeah.
Unfortunately for Fia, this next part just says, quick note on the oceans.
Oh.
In terms of invertebrates and fish living in the oceans, they were essentially modern. Different species than we have today, but same ecosystems, same, niches that we have today. Things like large predatory sharks, small fish that formed these large schools, bivalves and reefs made up of the same families and even in a lot of cases the same genera as they are today. The only things that are really noticeably different, if you were to go snorkeling, for example, in the Eocene, would be the lack of secondarily aquatic vertebrates, things like dolphins and seals and manatees and penguins. Those weren't around yet until sort of the end. We'll talk about that though. So, sorry, Fia.
That's okay.
The only other thing to really note about the oceans in this time are all of these weird climate stuff made a particular group of single-celled organisms very unhappy in the oceans. It's a group called Foraminifera. They're very important in the oceans. They are a really good bellwether for just how the ecosystems are doing. There's so many different kinds of them, but particularly the benthic ones, the ones that lived at the bottom of the ocean and would they almost work like fungi do on land, where they would sit on the ocean and at the bottom of the ocean floor and break down all the dead stuff that was falling from higher up in the water column. That's kind of what they do. And they did real bad during all these weird hot spikes and then dropping back off. They did not like that at all. Yeah. Anyway, back onto the land where things should be.
Oh. Interesting perspective.
Yeah. Where all the proper animals live.
Ouch.
But yeah, starting off with some of the
Didn't life start in the ocean?
Yeah, it sure did. And there's a reason it left.
Oh. But it kept going back, Gavin. It kept going back.
It sure did. You're right, it did. So getting up on land, starting with the terrestrial invertebrates. We actually have really good insect fossils from this time, thanks to lots and lots of amber deposits across northern Europe, particularly in the Baltics, as well as there's some in Greece as well, I think, but as well as I think somewhere in the British Isles as well, all across northern Central Europe. But for the most part, again, similar to what I was talking about with the trees and what I was talking about with the oceans, kind of the same stuff we see today, just their range was a lot different. So we see a lot of the same genera that we see in tropical areas today were found in this amber in what is now like Finland. So very much the same. Ecosystems were the same, just a lot more north or south than they are today. Moving on to the vertebrates. Starting off with reptiles. I really didn't see much about amphibians. There weren't a ton of, real weird things hanging on by this point for amphibians. There were some. I think there was a group called the Albinerpetanthids that kind of functioned like amphibian versions of chameleons in how they shoot their tongue. A lot of times their tongue fossils are confused for chameleons in places that chameleons shouldn't be. They, I believe, were still around at this time, but it's like frogs, salamanders, they were still around, just like they are today, and were more or less the same as they are today. Reptiles, though. All the major groups of reptiles were present and very similar to their modern forms with a handful of exceptions. In South America, there was a group of crocodilian relatives that were doing weird things like hunting on land and being fully terrestrial, not like semi-aquatic like today's crocodilians are. South America was doing all sorts of weird stuff while it was in its isolation. There's a handful of groups of turtles, also across most of the southern hemisphere, doing weird things like having club tails. Yeah, they're pretty neat. But for the most part, all of the non-bird reptiles were pretty similar to what we have today, with the one exception being snakes. Snakes were around and fully limbless by this point, but the sort of like garden variety snake, mostly called colubrids or colubroids, depending on how you want to do your taxonomy. These are things like your garter snakes, water snakes, ribbon snakes, basically all of the generally non-venomous snakes that aren't pythons or boas. They were like, their ancestors were around, but they didn't like, you couldn't really probably go out and find one like in your backyard. They were not nearly as abundant as they are today because they specialize in eating small rodents like mice. And those small rodents didn't really take off until grasslands did. So the snakes had to wait a little bit for grasses to take off so that their food would take off, and then they would take off.
Is grass a flowering plant?
Sure is.
Grass.
Yeah, it's weird. Like if you think of like wheat.
Yeah.
That weird thing at the top, that's its flower.
Oh, right. Okay.
Yeah. So it's not all flowering plants have like what you think of with like an orchid flower or something like that. A lot of times it looks different but has all the same parts if you know what you're looking for.
Yeah.
Plant people, don't come at me. I'm pretty sure that's its flower. But yeah. Anywho, onto the other reptiles, birds. Most of the modern bird groups appeared during the Eocene for the first time. Things like parrots and their relatives first show up in the Eocene. Falcons, songbirds, which are like 60% of all birds, hawks and eagles, chickens and other fowl, hummingbirds, they all have fossils for the first time in the Eocene. With birds, it's always a little tricky because they are very bad at leaving fossils. So it's possible, especially things like hummingbirds, maybe were around in the Paleocene just because they're so stinking tiny. It's kind of hard to tell, but I think their first fossils are in the very latest Paleocene, earliest Eocene. But yeah, so birds had been around for quite a while at this point, and we're now further diversifying into things as weird as hummingbirds are. Hummingbirds are so bizarre.
Yeah.
But, and of course, there were some groups around that we no longer have today. Namely some large flightless birds, like specifically the genus Gastornis. If you, like me, watched the like Walking with Dinosaurs, BBC specials, they had like a sort of sequel series of specials called Walking with Prehistoric Beasts, I think. That was all about the stuff after the dinosaurs. And so they talked about Gastornis quite a bit at the time when that was put out, I think in like the early 2000s, maybe like 2001, 2002. We assumed that Gastornis was predatory because I don't think we really had too many large predators in its environment at the time. Plus, most other large birds tend to be predatory, things like the terror birds from South America. And it had a beak generally kind of shaped like that. But as we've learned more about it, it was actually about a 5 or 6 foot tall herbivorous bird that mostly ate things like seeds and nuts.
Cute.
Yeah. And that lived all across parts of Europe and what is now Germany and other places in sort of Central Europe like that. Some of the largest flying birds ever were also around at the time. Part of a group called the pseudo-toothed birds that had evolved fake teeth in their beaks to help catch things like squid and fish as they sort of soared over the ocean, sort of like albatross do today. And some of these largest members had wingspans of over like 15 feet. So these were enormous birds. And penguins, which first showed up in the Paleocene, so the epoch before this, they start doing pretty well and spreading more across the southern hemisphere. I don't believe there are any penguins native to any part of the northern hemisphere. I think as far north as they natively get is the Galapagos. I don't know quite if that's above the equator or not, but yeah. So they start spreading around this time and then, continue throughout, time until today. So that's all the in my opinion, less interesting groups out of the way. Let's talk about the mammals. That should be...
All right.
That's more or less my catchphrase on this show. Let's talk about the mammals.
Is that a good title for the show?
Well,
it's not all about mammals. I don't think we can use that.
We'll put that on the list, on the short list.
Okay. Below Batman, though.
Yes, of course. So, up until this point in this episode, more or less everything... If you went back to the Eocene and did a nature walk, a lot of things would look and feel just like today, maybe a bit warmer. That's kind of it. The birds might be a little weird, but like there'd still be things like very similar to like blue jays and robins and stuff like that flitting through the trees and stuff. That would all feel very normal and natural to what you would see today. That is not at all true when it comes to the mammals. At the very beginning of the Eocene, there were only a few orders of placental mammals that are around today that confidently had a fossil record. I think it's pretty much just primates, rodents, and perissodactyls. Those are your odd-toed ungulates. That's your rhinos, horses, and tapirs. Basically every other large-scale mammal group originates within the Eocene at some point. These are things like your proboscideans, which are your elephants, artiodactyls and cetaceans. That's your even-toed ungulates, your things like cows, pigs, camels, giraffes, stuff like that. Cetaceans being your whales. Bats, carnivorans, which are your cats and dogs and bears and stuff. Sirenians, which are your manatees. Armadillos, pangolins. Basically everything has their start here. And this is why the Eocene has been referenced across the entire history of this podcast.
Mm-hmm. Yeah.
Also, the Eocene includes lots of extinct groups that were around then and continued for quite a lot of time. We just don't have them today. Things like anthocyanids, which are sort of colloquially called bear dogs.
Wow.
They're very neat. They have sort of the shoulders of a bear, as like big and bulky as that is, but then the back legs are a lot more slender. And then their head kind of looks like a very chunky dog head, like a big burly dog. Very strange group of animals that continued all the way through, I think, up until like the Pliocene, so like, only a handful of million years ago. Nimravids, which look so much like cats that for a long time we thought they were cats. Now we realize they're their own distinct family. Entelodonts, which you'll often see, we'll talk about them a bit more later. You'll see them called hell pigs online. They're not pigs. They're not particularly closely related even. But they were some of the largest, arguably carnivores, mostly omnivores, in their environments. Brontotheres, which look a heck of a lot like a rhino, but they're the dandelion things from the movie Ice Age.
What?
So we actually had an episode about the movie Ice Age.
Yeah.
The two things that are like fighting over the last dandelion of the season.
Oh, yes, okay.
Yeah, those are brontotheres. They look a lot like rhinos, but they're in the same group, but they're more closely related to horses.
Okay. Gotcha.
And then also, some of the strange animals we've talked about before in ancient South America that fill a lot of the same niches as some of the other hooved animals, but they're their own distinct group because South America's an island doing its own thing for so long. They all sort of crop up here in the Eocene. However, in order for them to pop up, they kind of have to replace the stuff that was there right after the dinosaurs went extinct in that 10 million year trial period that was the Paleocene. A lot of, like I said, real freaks kind of popped up. So in order for the groups that we have today to take hold, they had to sort of push them out. These were most of the things that had this sort of transition from the old stuff to the new stuff. That mostly happened in the herbivore niches. And I call them weird and freaks and stuff, mostly because they're not really related to anything we have today. That's the only reason that they're weird. But these are things like Uintatherium, which is maybe part of an early branching group of ungulates. Its body looks like just kind of a smaller elephant, but its head is very like knobbly. It has like two big knobs above its nose, two longer ones above its like eyebrows, and then two at the back of the skull. And then these big canine teeth that it must have used to like, probably males use them to fight each other is what I would guess. But they were herbivores. They ate plants and leaves and stuff, so they didn't really use them to hunt or anything. But weird. They were around in North America and Asia, but they go extinct by the end of the period. There's one of my also favorites is a genus called Arsinoitherium that, again, from the shoulders back, looks, again, kind of like a short elephant. But the head, it looks like it has two just giant, like, pontoons coming off of the front of its skull. Like, just these two, like, bananas that were each, like, 3 feet long. That, like, they're so big and unwieldy that, like, it probably couldn't have used them for anything other than looking intimidating. but that was kicking around Africa and southern, or like as Western Asia, Southern Europe, around this time as well. These guys, I think that group kind of makes it into the next epic, but they were sort of on the way out to make room for some of our modern mammals. This wasn't as much the case for the carnivores, though. The Eocene, sort of the main group of carnivores that you'll see talked about, is a group called the creodonts. That's not really like a formal group. It's what's known as a wastebasket. It's just like, well, it's this carnivorous thing that's not a real carnivoran. So it's not related to cats or dogs or bears or anything. But it's sure a carnivorous mammal, so we'll throw it in this group. So some examples are the genus Hyaenodon. This was a very prolific genus that was around for, tens of millions of years up until I think the Miocene. It has many, many species in it, and probably should be more than one genus, but I digress. Sort of looks like a bulkier cat's body with a more dog-like face, if that makes sense. Mm-hmm. But they could be as big or bigger than, bears, grizzly size or so, maybe a little smaller. Definitely a bit lighter than, they weren't as like heavily built as like a grizzly bear would be. So these are outside of all the carnivores we have today. So like cats and dogs are more closely related to each other than they would be to these things. But it sure does look like a lot of carnivorans we have today, which is why they're called Hyaenodon, which means hyena tooth. But they were not, closely related to hyenas at all. Some other placental carnivores around at the time were those things called entelodonts, the hell pigs, as you'll definitely see them called online if you ever Google it.
I'm sure.
So why do they call them hell pigs?
They vaguely look like pigs, kind of. Their teeth are very similar because they're omnivores.
Okay.
That's kind of the main reason. We used to think that they were more closely related to pigs. But then it was kind of just like, well, they eat the same stuff. That's why their teeth look similar. And being an omnivore generally means that you have pretty similar teeth to other omnivores. There's a long history of people finding pig or peccary teeth in the Americas and thinking they're human teeth. That's happened a lot. So there's been accounts of like people speculating that humans got to the Americas way before they did because, they found what turned out to be a peccary tooth. And peccaries are just sort of like America's, or the New World's version of pigs. They're related to pigs. They're not quite pigs, but for all intents and purposes, they're pigs. But finding a peccary tooth from like, the Miocene, 10, 12 million years ago, and people being like, wow, humans were here way longer ago than we thought they were, but no. They just look similar because they're omnivores, same as us. So similar thing going on with these guys and pigs. They are still artiodactyls. So they are in the same group, generally, as pigs, but they're pretty distantly related within that group. And they are, if you squint, you can kind of see like a pig on stilts.
If you close one eye and look
a
at
pig
it
on
sideways.
stilts.
Yeah. They're actually pretty closely related to hippos and whales. Not very close to pigs. But they, like I said, have the same teeth. They have like very big canine teeth that they probably used as tusks as well, potentially. And here's a fun quote of what one of the earlier genera called Archaeotherium looked like. This is a quote from Wikipedia. It looked like a cow-sized pig with a longer face, very wide cheekbones, and lumps on their face similar to male warthogs, but without the round nose of a pig. And that's paraphrasing. So, pigs have that, pretty signature, like round disc at the, end of their snout.
Mm-hmm.
They didn't have that. So basically it's just, while their teeth are similar to pigs, they're artiodactyls hell pigs.
Nice.
And they got to be quite large, particularly a little bit later on after the Eocene. But Archaeotherium was around at the very latest part of the Eocene, and it was, like, height-wise about as big as a cow. Much more slender, though, so not nearly like the weight of a cow, if that makes sense. Another close relative of hippos and whales was a genus called Andrewsarchus, and you'll sometimes see this called the largest mammalian carnivore ever. You'll kind of usually see it depicted in the shape of like a pudgy wolf with, proportionately shorter legs than a wolf. And the reason why it was thought to be this huge carnivore was when it was first depicted, when it was first described in 1924, only a skull was ever found to start with. As is, that's not unusual in paleontology, but, and they thought it was this close relative of, this other group. And so they basically were like, well, if we take the other one and scale it up to match the size of the skull, what would the rest of the body look like? And so the skull they found was just under 3 feet long, which is very big. So like almost my entire arm could fit inside its mouth.
Yeah, that's crazy.
And so if they had scaled it up to, match what they thought was a close relative at the time, this would have made Andrewsarchus about 12 feet long and over 6 foot tall at the shoulder. And based on the teeth, it seems to be at least more carnivorous than herbivorous. Still probably an omnivore. However, since then, it's been found to be pretty closely related to those entelodonts we just talked about. So instead of being that sort of pudgy wolf, it probably looked more like they do. But still, some things very large running around at this time period that could eat basically anything they wanted. And then to sort of round off our talking about the mammals here, let's just do a general speed round of some of our modern groups of mammals and see what they were up to and what they sort of looked like. Very, generalizations here. Because a lot of them were around but didn't have, they hadn't diversified and diverged a lot from the different groups. So, firstly, carnivorans. Generally looked like weasels with longer tails. They lived in trees and generally had like the really long bodies like you think of with a weasel. For a good general shape, you can Google the genus Miacis, which is just a fun name. But it's Miacis. It's an early carnivoran from the Middle Eocene. Just a long guy that lives in trees. Bats. Looked like bats. We don't really know where they came from. That's a long-running debate in mammal evolution, is where exactly bats fit. We're pretty sure, but without fossils, it's hard to tell. By the time bats show up, they look like bats. And they showed up pretty much globally around the same time, so it's hard to tell exactly even like where the first bats showed up, but we know they showed up in the early Eocene. Rodents mostly looked like mice. They hadn't yet diversified into the more weird forms for rodents, like porcupines or capybaras or beavers and stuff. I think technically the beaver family showed up at the very end of the Eocene, but in general, rodents, still looked much more like mice than they do things like beavers. Primates. Monkeys and lemurs had been split for a while, or the monkey side and the lemur side had been split since even potentially, pretty deep into the Cretaceous. But in general, primates probably looked like monkeys, but with sort of a longer face than we see in monkeys today. If you think of like a lemur, how they have that kind of like vaguely fox-looking face where they have a long snout, kind of, at least relative to like us or a monkey. More like that than like us with a very flat face. Artiodactyls. So these are your even-toed ungulates. So this includes deer, pigs, cows, camels, stuff like that. They mostly looked like small deer, but without any of the head ornamentation, really. That would come generally later on in the Oligocene and Miocene epochs for artiodactyls. However, as we talked about, things like Entelodonts and Andrewsarchus looked quite a bit different. They're artiodactyls and fit in this group, but the ones that would survive on and become deer, camels, and such, they generally shared a small deer shape. Perissodactyls, these are your odd-toed ungulates. These varied quite a bit. They diversified a bit earlier than the artiodactyls did. These ranged from the big rhino-like brontotheres, the dandelion things that I mentioned before from Ice Age. So they were big, rhino-sized, but there were also the small ones that, were like the earliest horses that were maybe a foot and a half tall. Proboscideans, these are your elephants and their relatives. They didn't yet have the big trunks like we think of, that is iconic of them today. Generally, they kind of look like tapirs. If you're not familiar with tapirs, it's sort of like a squat pig with a tiny little baby elephant trunk. And then lastly, for the speed round, cetaceans, which are your whales. And whales undergo by far the largest change of any mammalian group in the Eocene. At the beginning, their ancestors were very small and sort of the general size and shape of a house cat. If you're curious later on, something to look up is the genus Indohyus. Like I said, house cat sized, very scampery, like around the forest floor or something. But in less than 10 million years, it would go from that to the largest things in the ocean, to the genus like Basilosaurus, which was anywhere from 10, potentially up to 15 to 20 meters in length for an adult. So wow. Very long, very slender whales. And for us Americans, that is somewhere in the ballpark of 50 to 65 or so feet.
So yeah. Like a foot to 65 feet?
Yep.
In 10 million years.
Yep.
Jeez.
They must have been doing something right.
Yeah. Well, all the big marine reptiles were gone in the oceans. So being like the giant predators in the ocean, that niche was completely wide open.
Yeah.
They're very funny looking, the big ones around at this time, because even though they were that long, they only weighed a little bit more than like an African elephant today.
How is that possible?
They're just real skinny and very funny looking. They're so skinny and weird looking. So if you notice, I said the genus is called Basilosaurus, but it's a whale. It's saurus, you think of like a dinosaur or some other reptile. They thought it was like a mosasaur, a marine reptile around in the Cretaceous, when they first found it, because its vertebrae were so weird and it was so like long and snaky, they thought it must be a reptile. But no, it's a whale.
Wow.
And yeah, it's very funny looking if you look at it and then compare it to like a sperm whale or a blue whale. Very different proportions. Yeah, so that's the speed round. That's all the critters that were around at the time. So how does the Eocene end? What happens? Well, you've never heard of like a big extinction event happening at this time. So there wasn't a big asteroid or something that hit the planet, but basically, when Antarctica had its first permanent ice sheet, that's generally agreed as like the end of the Eocene, moving on to the Oligocene epoch.
That feels like more of an artificial like boundary, like, and all these are artificial, obviously, but like, is that?
That's not the official.
Okay.
Like with a couple of exceptions, every transition from one time slice to another does have like an official location, where it's like at this part in the rocks, below it is the older time, and above it is the younger time. And that's true of the Eocene to Oligocene boundary as well. That's just Antarctica getting its ice sheet is just sort of like generally that coincides with the other things that you see as the difference between those rock layers. And is likely the cause of the difference between the rock layers.
This is correlation, not causation here, or not, we're not just picking something at random.
Right. There is probably some causation here.
Oh.
Because this ice sheet probably really messed with global climate a lot.
Mm-hmm.
And that caused a pretty big faunal turnover. So not quite an extinction, because when an extinction happens, like when the dinosaurs go extinct, there's a lot of extinction, but not a lot of new species cropping up. A turnover is when there's a lot of extinction, but there's also a lot of new species popping up at the same time to fill those gaps.
Okay.
So this is there's a really noticeable turnover from the last of those weirdos going extinct, including things like those Uintatheres, the one with its weird knobbly head. Also including a very famous group called the multituberculates. They are a very rodent-like group of early mammals that had been around since the Jurassic period. So they were around for over 120 million years, doing great the entire time, but they don't make it past the Eocene. Likely due to competition from rodents and these changing climates. And so as the ice began to accumulate on Antarctica, mess with global climates, changed ecosystems enough that these old things couldn't quite hack it, and the new things that we continue to see up until today evolved to fill those niches left open in a very short, tight time frame. You can also see some of the things like in the geologic record in places where you don't have any fossils. For example, in Europe, as the ice was accumulating in Antarctica, that lowered sea levels. And so Europe, a lot of it goes from a tropical archipelago to a more proper continent, if you will. And you can see that in the rocks, where it goes from a marine environment to a terrestrial environment. And if I remember right, the official transition location between the Eocene and Oligocene is somewhere in Europe, I believe.
Very cool.
But yeah, and as the sea levels continued to drop, Europe, like I said, became a continent fully connected to Asia, which was already intermittently connected to North America, but with the sea levels dropping, that happened more often. So now animals were free to move all the way from like Iberia, like Spain and Portugal, all the way to North America. And so this also introduced a lot of new species to each other and increased competition all around the world. All the while, forests and stuff were continuing to sort of dwindle across the globe as conditions dried, gave rise to more open habitats that later on would make way for grasslands and prairies and savannas and stuff like that. And that pretty much brings us into the Oligocene, which we'll be talking about at some point in the future.
Awesome.
Yeah, this was...
Do we have a title?
We do.
I mean, what was the title? I'm asking.
I don't know. Well, that's for editing, Gavin, to figure out, I guess.
I like the second option about the mammals that you said.
Okay. I'll have
Let's
to...
talk about the mammals.
That's for editing, with, like, Gavin to figure out.
The Antarctic ice sheet, like, you know... I wish there was something we could do with that.
Yeah, right. Well, with the Paleocene, it was really easy.
Right.
Because I could just be like, you know, after the dinosaurs is I think what I called that one, and that one's catchy. That one actually did really well on YouTube, surprisingly. But yeah.
Thanks, everybody.
Yeah, thanks. Anyway, this is the ramblings of a tired man.
All right. Well, are we going to wrap it up now? And I guess we'll all find out together what you end up calling this episode.
Yeah, we sure will.
Well, thank you, Gavin, very much, and thanks to all of you listening. This has been episode 131 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, that was Gavin and Thea, and we will see all of you in 2 weeks. Take care, everybody.
This episode of I Wish You Were Dead was written by Gavin Davidson and hosted by Gavin Davidson, Mike Bryson, and Finella Campanino. It was sound edited and edited for YouTube by Gavin Davidson. Special thanks to former guests of the pod and to listeners like you.